Hi class, our focus lesson, as usual, will be based on PERT, ACT, and SAT type questions. Today we're going to be talking about factoring. Factoring will be part of your PERT, ACT, or SAT examination. Today we're going to talk about two types of factoring. The first type is the difference of two squares. And the difference of two squares takes on a particular type of format. Theoretically, the function or the expression will have the format of a square subtract a square, the difference of two squares. Now, when you see this type of equation or function on your examination, I want you to have very, very quick approach to it and break it down using this approach. A plus B, A minus B. Don't think, just do it. The difference of two squares. Now, for example, if I gave you a problem that looked like this. X squared minus 9. And I ask you, what are the factors of that expression? You would use this concept of the difference of two squares and be able to write it as x plus 3, x minus 3. We will be practicing these methodologies over the next few weeks leading up to your ACT, PERT, or SAT exam. But let's look at another example real quickly before we leave this concept. Suppose I gave you a problem like this. 9x squared minus 49. How would you approach factoring that difference of two squares? Most people don't recognize that it's the difference of two squares because they see the 9 here, but the 9 really is nothing more than 3 squared. And of course this is 7 squared. So if we went to factor this, it would be 3x minus 7, 3x plus 7. Alright? So in our focus lesson today, we're only going to talk about the difference of two squares. I will expand this to include the European method of factoring, factoring using the quadratic formula, factoring using basic diamond method of factoring, and factoring using greatest common factor. Okay? Now with that said, I would like us to move directly into our launch. Today, we're going to talk about parent graphs and how to actually transform graphs. You know, they have a saying that the fruit doesn't fall far from the tree. I like to use that expression to gather momentum as it relates to parent graphs, because you can only have one parent, you know. So our whole family of graphs that we're going to look at are going to be based on, first of all, we're going to talk about the quadratic function and the quadratic parent graph. Then we will talk a little bit about the cubic function and the cubic parent graph. Now, the quadratic. Any quadratic function has an exponent or a degree of the power 2. So our parent quadratic graph looks like this. Well, now we're in algebra 2, so we use f of x, we don't use y anymore. Y was for algebra 1, but now we're into functions. X squared. That is our parent quadratic function. Now the graph associated with this function looks like this. Opens up on the left and up on the right. okay? Now the negative of this function looks like this. And that graph behaves this way. Down on the left, down on the right. This is the parent, this is the source of where we're going to start looking at the transformations of this graph. Some key things that I want you to know here. This point here, the locator point, is very important. And it is denoted as X and Y, but in the framework, you will refer to it as H and K. Your locator point is key, and when we actually do transformations, I want you to identify where the new locator point is, and that will help you to identify the new transformed graph. All right, so it's always good to start for the parent. As I said before, the fruit doesn't fall far from the tree.